probably introducing the most controversial idea in mathematical history, and that is that pi is wrong in base 10 and that there's a better version or another way of calculating it in base 12 that yields a different type of answer, different type of number with different qualities. So I have written a book about this called Understanding Base 12 Math, How to Draw the Perfect Circle Using Dawsonal Geometry. And in this book, I show you how to plot 360 points on the circumference of the circle. So this book is available through Amazon. You can get it if you want to get ahead of these videos. But what I'm doing now is introducing you to the geometric pattern that we use to plot those 360 points. And I just want to point out that there is no pattern that does that in base 10. There's no way to actually plot 360 points on the circumference of the circle in base 10. So we're going to do it now using Dawsonal geometry, creating a geometric pattern on the Dawsonal Cartesian plane, or the base 12 Cartesian plane. So this is what that pattern looks like so far. You can see we've got this line going across here that has the length of 0.5 root 2, which is 5/12 in base 10. But basically we're dividing our 1 by 1 square into 12 by 12 smaller squares, and we're using that grid pattern upon which to base or draw or connect our geometric pattern that is going to allow for the division of the circle into 360 degrees. So these are the 2 points that we're starting with. This one has the coordinates of 0.7 and 1, and then 1 and 0.7. And you can see that I've drawn a line connecting 0, 0 to this point and that point. So the slope of this line here, we have a rise of 1 and then a run of 0.7. And here it is a rise of 0.7 and a run of 1. So what's great about that is that because we have this length of 1, we realize that any point along the x-axis is going to have a corresponding y-coordinate. So what I mean by that, if we were just to go over 0.1, then we would be able to go up the length of 0.07, go over 0.1 and up 0.07 and so on. And again, any number on the x-axis will have a corresponding y-coordinate, and any number on the y-coordinate will have a corresponding x-coordinate. So then what we can do is simply connect these points across like this. And again, all of these lines are going to be factors of 0.5 root 2. So the very first iteration, or the first example of that here, this little line segment right there is going to be the length of 0.05 root 2. Then this next step on this sort of inverted ladder is going to be 2 times 0.05 root 2, then 3 times that, 4, 5, 6, 7, 8, 9, dec L, and then do, a dozen. Again,